Okay, so the key thing here, do you see? It says there's 160 office workers. That means my very final answer must be 160 when I'm talking about cumulative frequency. Cumulative frequency means that we're adding up as we go along. Okay, so less than 100. Well, there's no one less than 100. Our weekly wage started at 100 being the minimum. Okay, so that's why that one's 0. Then 10 people who are less than 200, less than 300, it's 22, and the 10 people from earlier, so that would be 32. Add the 46 would be 78. 132. 150. And then look at that, 160. I knew it had to be 160. If it wasn't, I'd gone wrong somewhere, so it's an easy way to check. It says estimate, oh no, it says B, use the graph paper opposite to draw the cumulative frequency diagram for it.
So can you just say I can do that and then go on this?
What's that, sorry? What did she say?
I actually did it.
Move on. Too easy. Let me just plot it very quickly. 100, 200, 300, you always plot at the end of these categories. So 100 and 0, we can actually plot by there. Okay, and then 210, so that would be halfway in between there. Are we happy for me to skip this? Yeah? Basically, once you plot all those points, you can do two options. You can either freehand join them up. I always use a ruler. You won't get marked down for doing either way unless you really mess up your freehand and doesn't really follow through those points. If it goes sort of like way off, then it's not right, is it? If you do it with a ruler, you definitely get the marks. Okay, then I'm quite happy to skip that if it's the general consensus. Yeah? Yeah, so I actually go and join it up with my ruler. So I go and join it up like that. Okay?
If you were in an exam,
Yeah.
and the exam gave you a graph paper, what would you do? Like,
It would.
In the graph.
Oh, it was. It's just to do with our photocopy machines. Yeah, yeah. The WJC one, trust me, it'll definitely work. No, it will definitely work. Okay? Okay, and so... Have we got through the whole thing? Nearly. Yeah, you just join up all the dots, interquartile range. Yeah, I use a ruler.
Except you wouldn't have done it.
Okay, then, little bit of something to watch out for. It said about 5 litres. 5 litres is how many millilitres?
5,000.
5,000 millilitres. So, 5,000 millilitres equals how many centimetres cubed?
5,000.
5,000. 1 centimetre cubed is 1 millilitre. That's what a millilitre is. Okay? So, we're trying to get to 5,000. It says, by estimating pi is 3, show whether Carwin is correct. So what does Carwin say? The cylinder holds approximately 5 litres. So we do pi r squared, and then we times it by the length to work out the volume of that thing. Okay? So that is going to be 3 multiplied by 4 squared times by 10. So what's 4 squared?
16.
16. What's 16 times by 3? 48. And then 48 times 10?
480.
480 centimetres cubed. Carwin is way off. Even if it's 10 times bigger again, still be off. Okay? So, nowhere near.
Wait, if it's 10 times bigger, he would be closer.
Okay, yeah. When if it's 10 times
you would like.
he'd still be 200 less. It still wouldn't hold exactly that amount.
I mean, come on, give the guy a break.
No. It's 10 times off.
Okay.
Clown. Nowhere near. 5,000 centimetres cubed needed for 5 litres. Okay?
So would it only hold 0.48?
0.48 litre, yeah. That's basically a drink bottle, isn't it? About 500 ml, aren't they, your drinks bottles? Oh,
Yes.
we're almost done. How have we thrown through like a whole paper? We're in good shape when we're doing that because we did like a load of questions at the start. We did the phone. Yeah. Hang on, sorry, Kelly. Guys, can we be quiet for a second?
Because this is a nice paper, is our paper more likely to be nice or to be worse?
Oh well, I can tell you now. In my old school, they didn't like this paper at all. They liked paper 2 of this paper. Paper 1 was horrid, and they were all crying after the exam. It's quite natural that people come out after an exam and go, "Oh, that's the worst exam ever. It's so much harder than the previous years." And then when you're revising, you're like, "Oh, that one's not too bad." It always happens. Find the nth term for that. That's quite simple. That one because. See there? Why is this one a nice one? It's obvious. It's going up in the same pattern every time. It's going up in 4s. That means it is 4n. What's the number in front of 9? 5. What sort of 5?
Plus.
So it's a +5 that goes there.
So you know when it's different, and then you've got to find the difference between the second difference. What do you do then?
This is coming up, I think. Okay, so hold fire on that question. Okay. Karis says, thank you. Karis says that 149 is in Dewey's sequence. Is she correct? Explain your answer. Well, let's just stick it into that. If we can solve that equation, then it works. Okay. So take the +5 over, it becomes 144. And then divide that by 4. So half it would be 72. Half that is 36. Yes, because that is 36, it's the 36th sequence. Okay? If it was like 36.5, then no, because we're counting in 4s every time, and we're saying it's the 36.5 sequence, not counting up in half numbers, counting up in 4s. So yes, as it is an integer answer. Let's see what I'm writing there. Integer answer. 149 is the 36th term. Okay. Part B is looking reasonably tricky. It says Val works for a company that makes rectangular windows using small panes of glass. All of the small panes of glass are the same size. Val has drawn the patterns of the windows. I'm actually going to read off what the numbers are there. So we've got 3 by 2, which is 6. And I've got 3 by 4, which is 12. Sorry. Then I've got 4 by 5, which is 20. And there's this 5 by 4, which is 5 by 6. Sorry. So what's this? 36? Yeah.
Wait,
30,
5 by 6.
30. Okay. What I could have done actually, I could have written out what I was saying then. 3 by 2. And then this was 4 by 3. Then this one is 5 by 4. And this one is 6 by 5. Now, in some respects, if you can spot it, I've already worked out the nth term in my own head. Pattern 1, what do I do to 1 to get to 3? Add 2. What do I do to 2 to get to 4? 3 to 5? 4 to 6? What do I do to 1 to get to 2? What do I do to 2 to get to 3? +1, isn't it? It's going to be a +1 rather than times by 2 because it works every time. If you can spot things like that, I can tell you quite safely already that the pattern's going to be n plus 2 multiplied by n plus 1. Okay? But that means it's time to wake up, Karan. Come on. It's your alarm.
It is.
So adamant as well.
It's not.
For me, that way's better than doing what we're about to do, which is going to be the longer, fussier way. It says, Imran says there would be 110 panes of glass in Imran's pattern number 8. Now, if you're spotting there the link of what's going on, you'll be able to say it's wrong because pattern 8 would be 10 multiplied by 9, which is 90. I'll be interested. We'll have a quick look at what they've said in the mark scheme, but that's how I do it myself. What number is it? 12.
12i.
So what were you on? Yeah, look, see, 9 times 10 is 90. Okay, they've done 10 times 11, which is for a different number, isn't it? Okay, so it was 90. So then it says, Val says the pattern that n contains is n squared plus 3n plus 2 panes of glass. Is she correct? You must show you're working and correctly identify your answer.
Yes.
Now I've already got them worked out using the nth term. Because that was always 2 more than the pattern number, that was always 1 more, then the nth term must be n plus 2 times n plus 1. So n plus 2 times by n plus 1 will give me n squared plus 2n plus n plus 2, which is n squared plus 3n plus 2, which isn't that the same thing? So she is correct.
So what if I didn't do it like that?
Now, the other way to do it, which I'm about to write underneath, is that we use these numbers. So we say 6, 12, 20, 30. Look at the first difference between them. So we've got 4, 6, no we haven't, 4, 8 and 10. No, we don't have an issue with that. So we have difference of 2 again. If the second difference is constant, we know it is an n squared pattern. Okay? So what I'm going to write above this pattern now, our sequence, I'll just call that S for sequence, is the n squared pattern, which is 1, 4, 9, and 16. What do I do to 1 to get it to 6?
5.
Add 5. What do I do to 4 to get it to 12? Add 8. What do I do to 9 to get it to 20? And 16 to 30? 14? 5, 8, 11, 14. What's it going up in?
3.
So that's plus 3n. What would be the number in front of plus 5?
Plus 2.
Plus 2. There's the other way.
What's the
Oh, that's a bit more.
What's that, sorry, Lewis?
Why is the difference between 4 and 8?
Yeah,
Also,
like
the difference between 6 and 12 is 6.
Yeah.
Ah, it's 6. Right, sorry, yeah, because that, yeah, sorry, I knew there's something wrong there. Right, 6. There we go, that's now correct. Yeah, thank you, well spotted. All good? Yeah, so with these ones here, the patterns, sometimes you can spot them. The more you practice the patterns, the easier they become to spot. But otherwise, you can default and use the method that we've been looking at recently anyway. Okay? And that was the last question on the whole paper, is it? We've done everything?
Yeah.
Oh.
So,
Let's call it a day.